You know, every single meal you have ever eaten started its life as a tiny seed. But have you ever really stopped to think about what it takes to make sure that seed will actually grow? Well, today, we're going to pull back the curtain on the secret science of seed testing, the invisible, absolutely crucial quality control that our entire food supply depends on.
So here's our roadmap. We're going to follow a seed's journey from start to finish. We'll kick things off with its secret life, then we'll figure out what exactly makes a seed good. From there, we'll step inside the quality lab to see the science in action. Then, we connect that test to our dinner table, and finally, we'll talk about why all of this is so important for our future. Let's dive in.
It's so easy to just look at a seed and not think much of it. But let's reframe that. Think of each seed as a tiny, perfectly engineered piece of biological technology. It's packed with potential, just waiting for that perfect moment to spring to life. And that really brings up a massive question, doesn't it? What does it really take for something that small to become part of a harvest that can feed millions or even billions of people? You might be thinking, oh, it's just soil, water, and sunshine. But believe me, the story starts way, way before that seed even touches the dirt. The answer, the single most important foundational first step, is quality. It all comes down to that. Because if you start with a bad seed, all the farming, all the water, all the hard work that follows, it's all at risk of being for nothing. And that gets to the heart of it, right? Not all seeds are created equal. It's just a fact. Some are strong, some are weak, and some are, well, just duds. Seed testing is the science that sorts the superstars from the slackers. It's the quality control system that prevents a disaster before a single seed even goes in the ground. Okay, so what are these scientists actually looking for? What is it that separates a good seed from a bad one? Let's take a look at the blueprint, the key ingredients that define a high-quality seed. First up, we have purity. And it's pretty much exactly what it sounds like. If you buy a bag of corn seeds, is that what you're getting? Or is it corn mixed with other junk, like weed seeds that'll compete with your crop? Or what they call inert matter, dirt, stems, chaff. A purity test makes sure a farmer is actually planting a crop, not a field full of problems. Next, you've got germination. This is the seed's most basic job, right? Can it actually come to life? A germination test measures what percentage of seeds in a batch can successfully sprout and grow into a healthy little seedling, but under perfect lab conditions. A high germination rate means a farmer gets a full, productive field. Now this is a really important distinction here. Viability and vigor. They sound kind of similar, but they are worlds apart. Viability is a simple question. Can it live? Is the seed biologically alive and capable of sprouting? It's a basic yes or no. But vigor asks a much tougher question. Will it thrive? Vigor is all about the seed's strength and resilience, its ability to pop up quickly and grow strong, even when things aren't perfect, like in cold or dry soil. A viable seed might live, but a vigorous seed is built to win. So we know what makes a quality seed, but how do scientists actually measure all this stuff? Well, for that, we have to step inside the lab, where every single seed sample has to run a gauntlet of tests. The whole process really boils down to these three key steps. First, you have to get a sample that truly represents the entire seed lot. You can't test millions of seeds, after all. Second, you have the analysis, where all the different tests are run. And finally, all that data gets compiled into an official, accurate report. So here's a peek at what a purity analysis actually looks like. Scientists literally go through a sample by hand, separating the pure seed from any other seeds, from weed seeds, and from that inert matter we talked about. They weigh every little component and boom, you get a result like this. And hey, 99% pure seed, that is an excellent result. But what about viability? Here's a puzzle for you. A dormant seed gives you zero visual clues. It looks exactly the same whether it's alive or dead. So how do scientists figure it out without having to wait days for a germination test to finish? Well, they use a bit of clever chemistry. The secret weapon is a chemical stain called tetrazolium chloride, or just TZ for short. And what it does is it reacts with the enzymes involved in respiration, the actual process of being alive. So here's the magic. When you soak a seed in this TZ solution, any living tissue, the parts that are actively breathing, they turn this really distinct red or pink color. But any dead tissue, it just stays pale. It's this fast, elegant way to get a chemical verdict on life. It gives the lab a super quick assessment of viability in just a few hours. Pretty cool, huh?
All right, let's start connecting the dots. These lab reports, they're not just for academic curiosity. They have huge, real-world consequences. Let's see how this all plays out, from a simple test result all the way to our dinner table.
You see, these test results are incredibly powerful. They're basically gatekeepers. A batch of seeds can't be legally sold as certified unless it meets these super strict standards. And these rules, they're governed by national laws and international groups like the International Seed Testing Association, or ISTA. This system is what allows for global trade and, maybe most importantly, gives farmers confidence in what they're buying. And this table just lays it out perfectly. Let's say the standard for this crop is a minimum of 90% germination. If your seed lot tests at 95%, awesome. It passes, it's approved for sale. But look at the second row. If it tests at 85%, just 5 percentage points lower, it fails. That entire lot is rejected. It cannot be sold as certified seed. That could mean a huge financial loss. The line is that clear. Okay, so as we start to wrap this up, let's zoom out one last time. Because this isn't just about lab procedures or regulations. This is about securing our future. So why does all of this matter so much? The answer is right here. 8 billion. And counting. That is how many people on this planet are relying on successful harvests day in and day out. And the foundation, the very starting point of every single one of those harvests, is the science we've been talking about. And really, if you take one thing away from this, let it be this. Seed quality isn't just some abstract number on a report. It is the bedrock. It's the absolute foundation of our entire global food supply. It's this hidden science working quietly behind the scenes, day after day, that makes sure that incredible journey from one tiny, powerful seed all the way to the food on your table has the best possible chance of success. And that leaves us with one final big question to think about. In a world that's facing more extreme weather and a changing climate, that idea of seed vigor, a seed's ability to thrive under stress, is more critical than ever before. So how will this invisible science have to evolve to help protect our harvests in the future?